Okay, let's look at how we would differentiate something like this. Let's suppose we've got the natural log of 2x plus 1 times 3x plus 5, let's say. Something like this. And we want to find the derivative. Well, remember that the derivative of the natural log is just going to be 1 over x. And of course, we would apply the chain rule, and we would in this case here. And notice that if I differentiate this, okay, using this rule, I would get 1 over all of this in here, okay? 1 over that whole business, 2x plus 1, 3x plus 5. Then I have to apply the chain rule, so I need to differentiate this. Well, that is going to require the product rule. So I've got the derivative of the first times the second, plus the derivative of the second times the first. Okay? And then I go through and I simplify it if I can. So let's see here. Let me see what all this works out to be. I've got 6x and 6x. That's 12x. See, just clearing my parentheses. And then I've got 10 plus 3. That's 13. 10 plus 3 is 13. All that over 2x plus 1, 3x plus 5. Okay, so there's our derivative. So that's what we can do there. But one of the cool things about logs is that we have these properties. Remember that log of u plus log of v is equal to log uv. And also, we've got the subtraction u minus log v equals log u over v. So we have that one. And then another one is log u to the r equals r log u. So we work with those properties. Now, these properties can make things simpler for us sometimes. For example, let's go back and look at this same problem here. And what if I write this way? What if I write this as the log of 2x plus 1 plus the log of 3x plus 5. What if I do that first and then I differentiate? Okay, so let's see what happens. dy dx. Now, let's see what happens. I've got 1 over 2x plus 1 times 2, right? Chain rule. Plus 1 over 3x plus 5 times 3. See? Chain rule's going on there. Okay, now that's the derivative there. We've got the derivative. Now we could simplify it a little bit, and what I want to do is show that it's exactly the same as this. So let me come down the page a little bit, and here's what I have. I have 2 over 2x plus 1 plus 3 over 3x plus 5. Now, I'm going to go ahead and add these fractions together because I want to show you that it's the same as this. So I've got 2 times 3x plus 5. I'm just adding fractions here. 3 times 2x plus 1. All that over 2x plus 1, 3x plus 5. Okay. Now, if I clear my parentheses up top, notice I get 12x plus 10 and 3, that's 13. Yeah, look at that. Same thing. Exactly the same thing. So a lot of times, utilizing these properties will help us a great deal. Let's look at another one here. Let's suppose that I want to find the derivative of this. Let's suppose I've got the log of, let's say, 2x plus 5 over 3x plus 1 to the 7th. Now you can see, if we don't use our properties of logs, we're going to end up, you can just visualize that we're going to have kind of a mess, because we're going to have to differentiate. We're going to put 1 over this, and then we're going to multiply, well, 1 over this whole thing right here, and then we're going to multiply by the derivative of this thing. So that could get messy. You can visualize how that could be. However, what if we write it this way? What if I first of all view this way? I'm going to take the derivative of this thing. 7 times log of 2x plus 5 minus log of 3x plus 1. What if I view it that way? Now you might think, well, how did this happen? Well, look at this. This thing right here, let's just look at it here. This is, if we have the log of 2x plus 5 over 3x plus 1. Let's see what we can do here. I can bring the 7 out front. Okay. I brought the 7 out front. Now I can expand this out. So keeping the 7 here, I'm going to say this is the log of the 2x plus 5 minus the log of 3x plus 1. Ah, look at that. See? Same thing. So that's where I got that. But now let's go ahead and differentiate. So here's what we've got. We've got 7 times, inside here, I've got 2 over 2x plus 5. See? That's this first one. And the 7 is out front. It's times all of this. Minus 3 over 3x plus 1. There. Now we could go ahead and combine these, add the fractions if we want. Let me go ahead and do that. I've got 7 times 2 times 3x plus 1 minus 3 times 2x plus 5 over 2x plus 5 times 3x plus 1. Okay? And maybe you wouldn't want to do this, but just to show you how we could simplify it a little more. And so now I've got 7 out front, and on the inside I've got 6 minus 6, 6x minus 6x, okay? 2 minus 15, well, that's going to be negative 13 over this bottom. There. So you can see, using these properties of logs can be very helpful. So I would recommend that. And these are mainly these two properties right here are the ones that you would use. Well, and the third one too. But as you can see, we used each of these properties on these example problems.